just say it like Obama has a question. Like you know, okay, George W. Bush's manager and someone's style supports we can talk about
Hey, check. Check.
Okay, say that one more time. It's like an individual who supports that person. Oh, yeah. It's like perception of voters. Here,
Someday I'm gonna bring a nice microphone and hook it up to my computer and see if it sounds better.
It doesn't sound bad.
It doesn't sound fine when you walk. It sounds fine when you watch it.
Yeah.
Yeah, I know, but sometimes I want to just grab a nice microphone. And
Just for the sake.
no, it's not like I don't want to raise my voice. But it was very.
Okay, we're gonna get started in a second here, so if you get yourselves someplace, we'll start talking about. I mean, because look at this microphone. It's like the size of a needle. We could do better than that.
But we got top high school.
I can do better than that. I've got a better microphone than that at home. Okay, so we are going to go backwards and work our way. These last few ones tend to be time consuming. I'm sure you know that by now. So we have the gas at an SRS of 10 gas stations were recorded during a 1 week period. Prices are in cents per gallon. That might be important. Check the conditions and construct a 92% confidence interval for the average increase in price based on your interval. Can you refute the claim that the average price was 22 cents per gallon? Okay, 92 cents, we must be talking academic, or 92% confidence interval. This must be an academic question. So we'll go through all of these. Parameter. My mu is the...
Do we have to state parameter or can we say mu?
I'm just putting the parameter there for notes.
Okay.
Yeah.
Got it.
So the mu is the average gas price in... Mm-hmm.
Is there any way to make the font a little bigger? It's so small and hard to see.
Sorry, let's try it. How about that? Is that good? Average gas price in the location. I don't know whatever location they're talking about. It doesn't really say. During 1 week period. Okay, great. Excuse me. Thank you. Okay, and then X bar. By the way, is anyone literally writing out the word X bar? No? Okay, good. No, you shouldn't. You should draw an X with a bar on top of it, please. I just don't have that capability with my computer.
I've been putting
SQRT. You might want to start using the radical sign. X bar is the average gas price. In a sample of 10 gas stations. Okay.
If you say an hour sample of 10 gas stations, it's too long.
No. Okay, remember the word assumptions really means conditions. So number one, is this an SRS?
Yes.
I believe it is, right?
It says it.
Yes. Problem states that this is an SRS. 2, independence. So we're not sure how many gas stations there are, right? For this interval to hold, there needs to be more than 10 times 10 gas stations in the location. We have no indication. If this is true. So again, maybe it is true, maybe it's not true, I don't know. How many gas stations do you think there are in the San Fernando Valley? You think more than 100? There's definitely more 7-Elevens.
There's like 100 on Ventura.
And if you include this Costco,
Okay. And lastly, normality. Right, so this is where we're going to start to get into a little bit of trouble, right? Because we only have a sample of 10, small sample. We must check the graphs, right?
So if it's more than 30, we can just see it, take it up to 9.
Yeah, pretty much. All right, so let's see. We're talking about the gas increase, right? Oh, I missed that, isn't it? It's not the average price. It's the average increase. I totally missed that. It's the increase in gas price. Right, so we're going to have to put these increases into our calculator somehow. So can you read these around for me? 258, 255. Yeah, anyone. 256, 255.
260,
Thank you. 260,
270,
270,
286,
286.
wait,
Go back to 260 being the last one.
Should we go to eighth grade?
Yeah, and then 262, then 266, 265, 265, 258, and that's 10.
That's 10, right? Okay, good. Thank you.
270,
270,
286,
286,
270,
270,
276,
276,
267,
267.
274,
Mm-hmm.
270, 290, 268, 278.
Great. And then here I'm just going to do the difference between the two. So this is L2 minus L1. Okay, and those are the increases. Ooh. Look at this guy, 31-cent increase in 1 week. Don't like that. Okay, so we need to check our charts. First of all, let's check and see if there are any outliers. So it's the box plot with the 2 dots. This needs to be L3. And zoom 9. So there are no outliers. At least I don't see any here. Looks pretty symmetric, actually. Let's check. Oh. Sorry, we're going to screenshot this real quick. What is this? Okay. All right, so back here, let's see, first thing, paste. Good. No outliers. Again, you don't have to copy this on your test, but these are notes, so I just want to make sure you look at it. Yeah. No.
So do we have to say, do we have to say that we're gonna check the graphs? And then
Yeah.
it's a small sample?
If it says it's normal, we don't have to do this, right?
Yeah. If the population's normal, then you don't have to do anything. Just state that the
Explicitly stated,
yeah. If the if the population's normal, then you need to write something that says that since the population is normal, the sampling distribution is also approximately normal. Okay, let's go back to this. Let's look at the histogram. Again, zoom 9. Okay, that's not a great histogram, right?
That means it's slightly skewed.
I would say that's skewed right.
Yeah, it's skewed.
Yeah.
Mr. Furley.
Hi.
Mr. Tucker say if you can see John Jarrett Tano.
Yeah.
Yeah.
Who?
Mr. Tucker.
Oh.
Should I just
Sure.
look
Yeah.
at that?
Your pocket phone.
All right. Luckily for us, is right skewed. Luckily for us, having a right skewed histogram is not a killer. This isn't going to stop us from using a t-interval. Outliers would have stopped us, but histogram would not. Lastly, let's take a look at the normal probability plot. Hmm?
It's still viable if it's skewed.
Yes. All right, and that's pretty good right there.
That's pretty good.
Let's look at this screenshot again. Okay, so normal probability plot is approximately linear.
On our test, we have to draw the plot and say.
You don't have to draw unless it asks you to draw. So although the histogram is right skewed, we have little evidence to suggest the sampling distribution is non-normal. And just as a note, always link to the sampling distribution. That's why we're doing all of this, is because we want the sampling distribution to be approximately normal. So you need to make that link whenever possible. Okay, so this is a paired t-test or t-test t-interval for paired data. Okay.
yesterday, right?
Yeah, the one we did yesterday.
Because we had to subtract.
Mm-hmm. Okay, so let's see. We want to do one var stats on L3. No frequency list. Just calculate it. I think that's the only screen we need. There's that. And we need T star 9. I don't have the program on my calculator. So could someone... Oh, actually, I could just do this inverse T, right? Who needs a fancy program? Let's see. We want a 92% confidence interval. So 4% on the left. 9 degrees of freedom. .973. You should get the same thing, right?
Yeah.
1.973. Okay, so let's calculate. Confidence interval is equal to x bar, which is 14.9, plus or minus z star, t star 9, which is 1.973, times s, which is 9.22, divided by the square root of 10. Remember, we're going one more decimal place than our mean when we're looking at the standard deviation. Since this is a sample, we're using S and not using sigma, we're using S. So confidence interval is 14.9 plus or minus. Somebody calculate the margin of error. Thank you, 5.75. That gives me a confidence interval. Now I have 9.15 to 20.65. We are 92% confident that the mean increase in gas prices is between 9.15 cents and 20.65 cents.
The key that the reason we're doing the T paired one, it's because there's two. The prices that get preferred for that.
Were there any concerns we had with the assumptions? I think independence, right? Oh,
I was asking about, what was the name of it again? Paired T?
yeah, a t-test for paired data.
This right. Would you round to the nearest whole number for cents because you can't really have one.
But we're talking about an average.
Okay.
So average you don't round, ever. Let's see. Okay.
We're not sure if independence because we don't know.
Yeah. Since we don't know the number of gas stations in the area, this result may have bias.
So the answer to the second part of the question is no.
What's the second part of the question? Oh. Based on the interval can we say that the average increase is 22 cents? No.
But when we say it's unlikely, it's really, really unlikely.
Yes. That would be a better way of saying it. 22 cents is not in our calculated confidence interval. We have little / no evidence to support the claim that the average gas price increase was 22 cents. Notice that it doesn't say that it's not 22 cents. It says that there's no evidence to suggest that it is 22 cents. Yeah.
Oh, we don't include this in our conclusion part of panic because it's separate?
No, yeah, this is the second part of the question.
Okay.
So it'll be on the first page.
Yeah. This is the part B of it. This is not a yes or no question, notice. You may think it's a yes or no question, but it's not a yes or no question. You have to support the conclusion that or you have to support what you're saying.
So if like the confidence interval included terms where we say there is evidence to support that the average may be.
Or you have no evidence to refute, or our evidence suggests that the average gas price, let's just say 19 cents per gallon. Our data suggests that the average increase could be 19 cents per gallon. It could be any number in between 9.15 and 20.65. We don't actually know what it is. Like I said, that was kind of exhausting, right? One question. Especially when you have to do the entire procedure. Yeah?
Are we going to construct the whole thing within one of those boxes?
It'll be a big box if you do.
Okay, cool.
It'll be pretty small.
It'll be a page-long box, yes.
Nice size wall.
Yeah. Hey, nice box.
Yeah, 'cause this
Said the
actually-
undertaker to the corpse. That's kind of... Sorry. Okay, I don't think we have time to go into question 14. So let's instead do question 1. Question 1. We're looking for a 90% confidence interval, x bar minus mean. So first thing to consider is, are we looking at a sample or are we looking at a population?
Sample.
Good. It does say this is a sample of 13 fields. So we are looking at a sample. Sample of 13 fields. If you're looking at the population of 13 fields, then there's no reason to do any statistics at all, right? Okay, so 90% confidence interval of the mean yield. So we'll need to get our variables. Do we have an x bar?
Yeah.
What was x bar? 21. Okay, do we have s? 231? Do we have s? Good. Do we have n?
Yeah, 13.
Good. I think that's all we need, right?
Yeah.
We'll need, let's see, t star here, right?
Right, that was 13.
So we'll need t star 12. We have a small sample. A possibly non-normal
get to see it, like, that it's small sample?
No, these are just notes. Okay, so T star 12. Somebody get that yet?
1.782.
1.782, thank you. Makes it so much easier. Okay, confidence interval equals x bar, which is 220.231 plus or minus T star 1.782 times S 58.572 divided by the square root of 13. Let me know when you have a margin of error. I'm guessing it's 28.95.
48.96.
28.96. 96.
I got 28.94846, so 95.
95.
Do you think it'll have a difference?
No.
I'm asking for the test.
Yeah, well, for the test, yeah. Yeah. You should get this number right.
So what is it, 0.5?
Doesn't it depend? Yeah. Didn't we need one more decimal because it's one more than the mean?
Yeah.
Like before that?
So wouldn't it be
28.9.
But before that, like for the
Mm-hmm.
standard error,
Mhm.
wouldn't we need 4 because the mean only has 3 decimals?
Yeah.
Okay. Well,
What do you
when
want?
I did that.
What's
I got 28.9.
5721? Okay, good. And what do we get here? 28.9.
4?
826. Okay. And that should be good enough for us. Okay. And we're packing it up.